Hey everyone, thanks very much to Sprout Social and Bill for hosting this event, and thanks for the warm intro. So my name is Tormey, and tonight I'm going to be giving a presentation on React Native entitled When to Go Native Over JavaScript. So before I get into my talk though, I'm going to give you guys some background on me and my career so you can understand my perspective when I talk to you tonight about this subject. So, as you might have gathered from my accent, I'm Irish, but I didn't come to you today from Ireland. I came all the way from the West Coast, from San Francisco specifically, where I've been living and working for the past 10 years. Now, for most of that time, I've been working as a mobile software engineer. I started out doing native iOS and Android development at a few startups you've probably never heard of because they don't exist anymore. And then I moved on to work at some big companies. I spent 2 years at Apple working on the core audio team, mainly doing C++ and Objective-C. I then went on to work at Facebook, where I spent several years working on the main Facebook iOS app. I worked on the search team and the buy on Facebook team. I did do a little bit of React there, a tiny little bit, not that much. I spent most of my time doing Objective-C++ using a framework that was inspired by React called ComponentKit. So fast forward to today, and as Ben mentioned, I work as a consultant who specializes in mobile. I do mainly iOS, Android, and most pertinent to tonight's talk, React Native, which I think is absolutely fantastic. So the inspiration for this talk is some work that I did for a client of mine, a medical marijuana startup in California called Ease. The TLDR version of what Ease does is they're basically like Uber Eats except for weed. So if you have a condition and you need medical marijuana, you basically go to their website, you place an order, and that order gets sent to a driver who then goes over to your house and gives you your product, and you can either pay with cash or credit card. So I wrote the consumer app for Ease that is in the iOS App Store and Android App Store. It's geo-fenced to California because I don't believe marijuana is legal over here. And I also wrote the driver app. So this talk is mainly going to be a case study about why we couldn't do the driver app 100% in JavaScript. So before I go any further, I want to conduct an informal survey of the audience. Don't worry, I'm not going to ask you if you smoke weed or not. How many of you have written an app with React Native? Ooh, okay, I'm scared now. How many of you have written apps using frameworks like Cordova? Okay. And how many of you would consider yourselves native iOS or Android developers primarily? Okay, one. All right, okay, cool. Okay, let's move on into the talk. So what this talk is not about, unfortunately, I'm not going to be talking about UI performance. That is a really, really, really big topic. In fact, it's so big, I wrote a blog post about it, which you might find interesting. So if you go to my Medium blog, launchdoor.com, I wrote a post called I Made React Native Fast, You Can Too. I basically take the sort of interview question that every native developer gets asked. I have a list of images, it's slow, could you make it fast? I did this for Android with a React Native app where I performed various different optimizations, and I talk you through using basically Android Studio to profile your app's overdraw and memory characteristics, as well as a few other native developer tools. And then as I make it faster in JavaScript, I end the article by porting the list of images over to native code, and plot twist, it doesn't really get that much faster, and I explain why. So I'm not going to ruin the surprise. You can go read that article. It links to a GitHub repo with all the source code and a bunch of pull requests that show step by step how I made it fast, as well as graphs and performance information data that you can reproduce yourself in your own simulators and emulators or whatever. If you do care about how React Native works and you want to figure out how to get the most performance out of your app, there's a guy from Israel, Tal Kol. His Medium blog is absolutely amazing. He runs mobile engineering at Wix. There's 2 articles by him that are actually seminal to understanding what the performance problems you're likely to run into React Native are. The first is performance limitations of React Native and how to overcome them. The second is recycling rows for high-performance React Native list views. Those are great articles if you care about that topic. I'm unfortunately not going to be covering them tonight. I told you about this driver app, and you're probably asking yourself, what does this thing actually do? And most importantly, how is it similar or different from apps like Uber Eats? Well, If you have ever ordered food online from one of these startups that basically sits between you and sort of a restaurant, the driver of the person who's delivering the food probably has an app on their phone, and they're probably going from the restaurant to your house and dropping off the food. Ease is slightly different. So the reason why Ease can't send medical marijuana products through the post is that medical marijuana is not legal federally, and therefore you cannot use the US Postal Service to use that. Basically, what they have is they have the drivers go to a depot and they pick up a case full of product, about 3 or 5 grams worth of medical marijuana products. They're small, they sit well together in the car. These cars then need to drive around a geographic area that they're assigned to. So in the Bay Area, that's Oakland, San Francisco, or San Jose. And basically, when you, the consumer, place an order, these cars are broadcasting location continuously. The car with the products that map your order gets mapped to you, the customer, the closest one, and they come, they drive to your house, they pick out the stuff from the case, check your ID, and then they confirm the order and drop it off, and they collect payment if necessary. So that's what it does. So who here wants to see me order some medical marijuana? I have a video. Yay! Okay, so what I'm going to do here is go to the Ease website and order some Terra espresso beans. Don't worry, I'm not having them shipped to Sprout Social. This is in California, and it's a dev server. Don't tell my mom about this. Okay, so I'm placing the order, and now we're going to switch to the iOS simulator, and we're going to actually see the order come through any second now. And this is what the drivers would see in their app. So this is a dev build of it. So yeah, they see the address, they can go in, they check the order details. There's another screen that I don't show here that shows the inventory of the driver, and then that green button there will take them into Waze, and they'll go off and they'll navigate to the location that they have to actually service. So the question that you're probably asking yourself right now is, hey Harry, why can't we do this all in JavaScript? So, in order to explain this concept to you and to talk you through these issues, I've actually prepared a little demo application. And this demo application is a React Native app that broadcasts its location to a REST endpoint. Now, the app obviously is in the foreground, location polling demo. In the background in the terminal, you're going to see basically a Node.js app that's listening on port 8080 and is printing to the terminal all of the posts that it receives from the actual app. So this looks like this. And there it is, just showing a hard-coded Latin long for demo purposes. And that's all that is. The source code for this demo application is up here. But before you go downloading that and cutting and pasting it directly into your delivery app, this is deliberately broken. There's actually a pull request on this repo that fixes it. And I'm going to talk through the reasons why you can't currently do this purely in JavaScript with React Native. And that's kind of the subject of my talk. But if you want to check that out, it's there. So, okay, the naive implementation of this in JavaScript, if you're a web developer, you've never done development before, native development before, will be to install a third party like poll or set timeout or whatever, and have it periodically wake up your app and make a post with your lat long to a location, a HTTP post endpoint. Why can't you do that? What is the main reason? And the main reason for that has to do with the very nature of mobile devices, right? And that is background modes. So think about it. If you didn't have some way for the operating system to say, applications stop working, every single application that you ran on your phone would be running continuously, and that would drain the hell out of your background, your battery on your device. So most operating systems, like Android and iOS, have this notion of your app being in different states. When it moves from the foreground to the background, when you lock your screen, the app basically gets suspended or different services shut down depending on the state that it's actually in. So there's various different background modes, like inactive, active when the app is in the foreground, background and suspended, and of course not running when the application is not running at all. So the reason why this is important is if you go back to that demo that I showed you originally, you might have noticed, if you were very perceptive, that when I moved it into the background, it was still posting to that terminal. So you might say, well, Harry, I installed this poll library, I did all this stuff, it worked in the simulator, so we're ready to roll this out to production to all of our drivers in our fleet. What could possibly go wrong? Well, the simulator fundamentally behaves very differently from your actual device. So if you're testing in a simulator and it works, it's not time to ship. You need to test it on a device. So if you ran that same code on a device, you hooked it up to Xcode or used Expo or some other kind of technology to get it onto the device, if you foregrounded it, it would stop working, it would stop posting to the server. The other thing that you need to be aware of is it's not just enough to test on the device, you have to test it with the app actually backgrounded. So if you go back to our driver app, you might have heard me say that our drivers use Waze to navigate to a different location, right? So most of the time your app is not actually in the foreground, it's backgrounded. Or in the case of Ease's app, the Ease driver app spends most of its time in the background. The other thing that also can happen is, even if your app can run in the background, depending on how you've set it up, it might be killed after a certain amount of time. So generally, if you're testing a lot of the stuff, you want to leave it running in the background for 8 minutes or longer on iOS or 10 to 20 minutes on Android. Also, you want to test it with the device unplugged and on Wi-Fi. These are all things that can affect an app that has to run for a long period of time in the background, and should be something that you take into account when you're doing mobile development using use cases where basically you have to do a lot of background tasks. That's just a note. So you're like, okay, Harry, we're all web developers here. We don't care about any of this nonsense that you're talking about. Is there a third-party library that will magically make all of this go away? So you immediately go to Stack Overflow or Google or DuckDuckGo or whatever you're using. You type in all this stuff, and you might come across React Native background timer. And you're like, okay, well, can I just slap this into my app and basically have this magically make all of this work? What's the answer to that question? The answer is no. So if you look under the hood, this is based on something called executing finite length tasks. And if you look at the iOS developer docs around this, you'll find they're a little bit vague. So executing finite length tasks, and that's the actual iOS developer name for it, basically allows you to get a little bit of extra time to complete a long-running task, right? But they don't actually specify how much time you get. So if your app is going from the foreground to the background, maybe you're performing an upload or some sort of computation that you really want to finish, the operating system will give you a little bit of extra time to do this. The problem with this is that Apple doesn't specify in the developer docs how much time you get. So when Apple is vague like this, you really want to be aware, because next week when they run out their new fantastic operating system features, they could drastically change the characteristics of this particular thing. So if you look around on Stack Overflow, you'll find that this gives you roughly about 3 to 5 minutes worth of extra time for your application to run. So if you remember the use case that I outlined, Ease is running a distributed warehouse with all of these cars rolling around. Most of the time, if they're on an order, your app is going to be in the background. It's going to take probably longer than 3 to 5 minutes to get from one point of San Francisco to another. And so this is not really going to be a good fit for this. Also, as well, you need to be continuously polling. So it's not just a one-shot 3 to 5 minutes in this particular use case. You need to be continuously able to wake up the app. So what's the way around this? Well, the good news is that Apple recognizes that certain use cases require you to be able to run for long periods of time in the background. They include location, if you're doing audio, if you're doing voice over IP, Bluetooth LE, long-running background fetches, stuff like that. So they do give you a way to actually do this. The way to get at this is go into basically your Xcode settings for your project, go into capabilities and click background modes. The bad news about this is that each one of these use cases has special kinks and quirks to it. There's not just a one allow me to run in the background mode, click yes button that you can just click for this. And the reason why they do this, again, comes down to battery life. So in this particular case, we're going to be talking about location updates because it's pertinent to my client's needs. So again, in order to enable us to run for long periods of time, you need to select the location updates capability. So when you do something like this, if you ask to update location in the background or Bluetooth LE or use the camera or microphone, you have to actually ask your user for permission. So you do this by putting a key, which is NS location always usage description, into something that's known as a plist. So it's basically a set of configuration options for your application that it will use at runtime to determine what it needs to do. So when it pops up, when you ask for the location permission, it'll pop up a dialog that says, we need your location in order to post it. I wouldn't use that copy if I were you, but I just stuck that in. So, okay, so how do you actually do this in native code, right? So this is somewhat of a contrived example. So I stuck this native code to create a location manager into my application's app delegate. So for those of you who are not native developers, the app delegate is basically the entry point into your iOS application. It's usually where you sort of do your sort of initial application setup, pick the view controller you want to play, all that kind of stuff. So you wouldn't normally do this because as soon as you start up this app, it's going to immediately ask your user for permission, saying, hey, can I use like your location and stuff like that, and they might be shocked and say no. But for the purposes of this demo code, it's fine. So now that I've done this, now that I've sprinkled in this sort of magic native voodoo, will this poll function automatically work? Can I just rely on this and will everything be hunky-dory? And the answer to that question is again, no. And if you go to Brat Vatna's feature request, this is one of the main developers on Expo, a really excellent tool for developing React Native applications. He has a feature request about this, and he explains that basically React Native timers, the stuff that poll is based on, the stuff that set timeout is based on, don't work in the background. For long periods of time anyway. He explains it there. You should check it out. It's pretty good. So what you actually have to do is this horrible looking Objective-C mess here. It's not actually that bad. This is mainly to show you that it's not really that hard to wrap native code. It's included in the pull request there. But basically what I'm doing is, and again, I'm simplifying this quite a bit. I'm using an NS timer, an Objective-C timer, to continuously poll. So the combination of this, which you've wrapped in such a way that you can access via JavaScript, via a React Native library, and the kind of capabilities which I showed you earlier, which you could package up in a library, will allow you to do long-running background location tasks. All of that can be found on my GitHub repository in the example that I actually gave. So there's some things I think I should note, you should note at this point. So the driver app that I wrote is cross-platform. We have Android and we have iOS users on it. The native code that I've shown you in the example is iOS only. If there's interest, I could put up an Android version of this, and I'm going to talk a little bit about Android later on. But 90% of the driver's app code is actually React Native JavaScript. The only portion that we need to do is this long-running location polling stuff, and mainly that has to do with the security and specific requirements of my client. The other thing to note is if you guys are familiar with code push basically allows you to do over-the-air updates with JavaScript. Code push doesn't work with native code. So if you install any React Native libraries or if you write any custom native code, you can't push it to an app that's running it, or you will have basically a big crash. All your users will hate you. Now, the good news is that code push allows you to sort of tag your binaries or to target code push to particular binaries. So if you're building an iOS and an Android app, you could say, okay, this is version 1.2, and these have these changes. 1.1 doesn't have the native changes. So when you do your code push with, say, some new JavaScript styling or some stuff that's not related to that native code, that will be pushed out to version 1.2 and 1.1. So it's actually very easy to sort of like avoid this. But if you didn't know this and you're just like, yeah, I added some native code push to production to everyone, and then you suddenly see your Fabric or your Crashlytics or whatever blow up with loads of crash reports, you might want to do a rollback really quickly. Just FYI. So should you do this? Should you basically, you might be thinking like, Harry, I have this long-running task. It's not necessarily location-based. Should I just use your technique to do this? No. So Apple basically has very strict guidelines about their apps, right? So if you're not a location-based app and you go in and you click a capability and you say, I want to use location, and you're basically just using this to keep the phone awake so that your app can do some random sketchy thing in the background, Apple will most likely reject you when you're going to code review. So the Ease drivers, they work for depots, and depots basically use Ease's software, so they're paid to use the driver app, right? So the other thing about this technique is that it's really horrible for basically battery life, because I'm continually posing the server. Because a lot of these drivers, they're driving around San Francisco and Oakland with a few grand's worth of product in the back of their car. And a lot of them, they might park their car to conserve gas for a couple of minutes. Maybe they'll take a break. We need to know where they are at all times. Like the correct way to do this is probably to use a significant change location service. And basically what that does is it only wakes up your application if you move, right? So for most consumer applications where you don't need to do this polling for security reasons, you probably only want to send basically your location when the user moves around. Anything else will really drain the battery life. The other option, if you really don't want to deal with a lot of this native stuff, is this guy, Chris Scott, from TransistorSoft, has a really awesome library, React Native background geolocation. He is a super responsive guy. The iOS version is open source and free. He charges like $400 for the Android version, which would be a lot less expensive than hiring me to hand roll something for you. He's a really great guy. We couldn't use his library because, again, we have my client had really weird requirements, but it's totally awesome. You should check it out. He's put a lot of work into it. He's not that much. It's worth doing. So again, further reading. So the actual fix is here, this pull request. There's also Android, and there's really good docs about wrapping native code for Android and iOS on the Facebook React Native page. It's really nice. There's also, if you want to know about like background locations or just generally any native stuff from an iOS developer's point of view, Ray Wenderlich has a really, really great set of like background mode tutorials where he goes through a bunch of use cases that he didn't talk here, like Bluetooth. I think he does music. He does a bunch of these things. So if you combine that with wrapping native APIs, like don't be afraid to jump into this stuff. It's really not as hard as you'd necessarily think, and you'll learn a lot from doing it. But even if you just want to understand the theory so that if you're looking at someone else's library, you can make an informed decision, I highly recommend checking out that site. It's really good. So what about Android? Well, I mainly do iOS, so I'm not going to focus super closely on Android because that's kind of a topic in and of itself. But one big advantage that Android has is it doesn't actually need to ask for permission to run in the background for a long time. So Android has this concept of services. If you want to do something like this, and what we do is we have a service that runs as a general entry point for keeping an app running in the background. We use broadcast receivers to talk to our React Native libraries. So when our app starts up, we start like a geolocation service. It pulls the server. It talks to basically our React Native library. We tell it to start and stop, and we pass basically our data back and forth through that. So again, the reason why you want to use services versus like some of the other libraries for activities that are out there is that services have a higher priority than activities. And basically, an activity, by the way, is kind of like if you have a screen on Android, it's an activity, and it's analogous to a view controller if you're coming from an iOS background. It has its own life cycle and stuff like that. But basically, the operating system, Android, prioritizes services over activities. So even if you have libraries that do stuff in activities, the activity is still likely to be killed with before the service is. So if you're thinking about having sort of a resilient, long-running service on Android, you probably want to do that in a service and not an activity. Again, if you want to know more about like how services work under the hood, Google have excellent docs on it, which I've linked to here. So I am teaching a React Native intro workshop that Ben has put on this Sunday. If you're interested in that, as Ben was saying, let him know. I'm also putting together a more advanced React Native workshop that will dig into stuff like performance optimization, how to choose navigation stacks. If you've done any React Native, you'll probably know that like the third-party ecosystem can be a little bit like intimidating. Like there's like 5 navigation stacks right now, and a lot of them break support on things like accessibility. They have overdraw issues, so you have to kind of thread carefully when picking those. I'll be covering that, how to profile and optimize and improve performance with stuff, and I can also customize it if you guys are interested in anything else. Again, my medium is launchdrawer.com. I'll be writing more about React Native there. My Twitter is htormey, and yeah, that's it for my presentation. So we have a bunch of time for questions. Does anyone have any questions? Oh yeah, and thank you everyone again for listening to me talk.